Hello all, let's start section 6.2. 6.2 is the derivatives. Before talking about derivatives, what is derivatives? Let's first talk about average rate of change, which is a topic of algebra. The average rate of change, if I denote average rate of change as a AROC, a rock, average rate of change. Average rate of change means rate of change between 2 points between 2 points of a function. What does it mean? If you look the graph of f of x on the right side of the screen, I want to find the average rate of change between point P and point Q. Of course, point P has a coordinates which I named it x1, and on the y-axis it will be f of x1, and point Q has a coordinates of x2, and on the y-axis I name it f of x2. If we look at the function is increasing. If I look from point P, let me change the color. For example, if I use red, the function is increasing. It means the rate of change is changing, right? The rate of change is increasing. The function is rising. Instead of studying this change on the function, what I do, I'll pick up 2 points on the function. I'll draw a line, which this line will be your secant line. And secant line is a line that intersects from the geometry that you studied in high school. Secant line is a line that intersects a circle in 2 points. If I draw this secant line, if I calculate the average rate of change in this line, it will be the average rate of change in my function. All of us, we know that the slope of a line equals to rise over run, which we studied in school. For us, the rise is delta y, change in y. The meaning of delta y is change in y. And run is delta x. It means change in x. Correct? It means change in y. Delta y actually means x2 minus, and y2 minus y1. Or in our case, because I changed the name, delta y will be f of x2 minus f of x1, which is the same as y2 minus y1. Delta x will be change in x. It means x2 minus x1. If I plug in these in my slope formula, then the slope of the secant line will be equal to f of x2 minus f of x1 over x2 minus x1. This formula, f of x2 minus f of x1 over x2 minus x1, represents the average rate of change of the function f. Correct? In the past, they introduced always slope of a line. For us, means the slope of a secant line means the average rate of change. Correct? Then I can say the average rate of change, which is the slope of the secant line, equals to f of x2 minus f of x1 over x2 minus x1. This formula that you see here, usually we use this formula in algebra, correct? We use an algebra. Now, I'll give you another formula that usually we use it in pre-calculus, and we are using it in calculus, and which is the same average rate of change. Serve as the only thing that will be different here will be the notation. I'll give you that formula, and from there we do few examples of the average rate. Now, in this graph, which is the same graph, again I have a function of f of x, and I want to find here the formula for the difference quotient. We call it difference quotient. What is difference quotient? The meaning of difference quotient is average rate of change. It means the slope of the secant line. Let's create a formula. For example, I name this point x1. Definitely on the y-axis, it will be f of x1. Instead of naming this point x2, I will name this distance from x1 to x2 h. If this distance is h, then this point will be x plus h. Let's even remove x1, just name it x. Correct? If this point is x plus h, definitely on the y-axis, here I'll get f of x plus h. It means the coordinates of the P will be x, comma, f of x, and the coordinates of point Q will be f of x, x plus h, and f of x plus h. Let me make it smaller because I want to write there. The coordinates will be x plus h, comma, f of x plus h. Now, again, if I want to write the slope formula, difference quotient, which is the slope of the secant line, will be equal to f of x plus h, which represents y2, right? The same thing, minus f of x over change in x, which will be x plus h minus x. If I simplify a little bit the denominator, then the difference quotient formula, which is the slope of the secant line, will be equal to f of x plus h minus f of x over, you can see clearly here that x cancels out with x, and I'll get only an h. This formula, we call it the difference quotient formula. It means the average, again, average rate of change of the function f. Totally the same idea, only notation here is different. The notation is different. Instead of f of x2, we are using x plus h, right? F of x is f of x. It's the same notation. This formula can calculate the average rate of change between 2 points of the function. Now, Average rate of change means actually, in pure English, how fast, how fast uh, the function is rising, which means increasing, or maybe decreasing. For example, in this graph, function f is increasing. How fast it's increasing, that's the average rate of change. An average, on an average. We are talking here on an average. On an average, how fast a function is increasing or decreasing, and that will be the average rate of change, the meaning of average rate of change. No more only the idea of, oh, we are looking for the slope of that line, of the secant line. No, slope has a meaning for us. It means we are looking for the average rate of change. Now, I'll do an example and I'll show you how we can use this formula, f of x plus h minus f of x over h, which is the average rate of change, uh, in business, how we are using it to find the average of something, correct? Now, example number one, the total profit in thousands of dollars from laptops sold X weeks after the tech convention ended and introduced the new model is given by P of x equals zero point 0.1 x squared plus 4x. Part A. What is the total profit after 4 weeks? The function is given as a, which is a profit function, P of x equals zero point 0.1 x squared plus 4x. We want to find the total profit after 4 weeks. It means we have to find P of 4. P of 4 equals zero point 0.1 times 4 squared plus 4 times 4. It means P of 4 equals to 3.2 if you do the math in your calculator. 3.2, because we are talking about thousands in dollars, it means the total profit after 4 weeks will be $3,200. Correct? Part B, the same way it's asking how much will be the profit after 10 weeks. It means we are looking for the P of 10, total profit after 10 weeks, which will be 0.1 times 10 squared plus 4 times 10. And if we do the math, P of 10 equals 14, which for us, it means the total profit after 10 weeks will be $14,000. Part A and B is actually, we studied in 2.1, 2.2, how to evaluate a function. A function is given to you, you are evaluating it at 4 and 10. Now, part C is asking what is the average rate of change. To do that, even I want to do here a graph for you. I want to show this in graph, and after that we can use our formula and we can find the graph, right? Or we can say what is the average rate of change. As you see in the graph, after 4 weeks, the total profit was 3.2, which is 3,200. And after 10 weeks, the total profit gives me 14, which is 14,000. Correct? This function, if I name it the P function, correct? The profit function, P of X, is actually an increasing function. Now, I want to find the average rate of change, correct? If I draw here my secant line, easily I can find the average rate of change, correct? It means the average rate of change between 4 weeks and 10 weeks will be 14, which is P of 10 minus P of 4 over 10 minus 4, which for us, P of 10 is 14, minus P of 4 is 3.2, over 10 minus 4 gives you 6. If you do the math, it will be 1.8. 1.8, because again, we are calculating in thousands, means $1,800. You see the top of the fraction introducing the money in dollars, and your x-axis representing weeks, right? Then it will be $1,800 per week will be the average rate of change of the profit, correct? It means if the company had been earning more profit over this time in a kind of uniform fashion, it means the same amount of profit every week. You see, when I'm saying uniform fashion, I'm talking about secant line. It means the rate of change, if it's constant, correct? That amount of profit is changing $18,000. The rate of change will be $18,000 per week, correct? This example, I don't want to do a lot of examples here because soon I will handle the difference quotient formula for you, and also I will cover the actual topic is the derivatives. We will talk about the actual derivatives. What is derivatives? We will do more and more examples there, and we will learn how to find the average rate of change of a function, or how to find, on that time when I explain to you what is derivatives, the instantaneous rate of change of a function, correct? I will stop the lecture here, and I'll record a part 2 of this lecture. In part 2, I will cover examples, how to find the difference quotient of a function, and also we will do a lecture there on how to find the derivatives of a function. See you all in part 2 of the lecture.